Good. All right. Good afternoon, everybody. There seems to be a lot of people interested in some offensive security today. It's a good sign. Anyways, my name's Chris Scott, as you can see, and I'll be talking about some offensive software I've written based on wireless penetration testing. It is a framework that's modular designed. Hopefully, it's a lot to give to the community now. It's the first of its kind in the wireless spectrum. I think you'll like it. You feel free to follow me on Twitter. It's a great place to follow me. You also see that I run a Freenode channel. It's basically an open source Freenode channel. We're all about contributing code. There is no real basis to the channel, so it's not project driven. That way, anyone that's a pen tester can feel free to ask any type of pen testing related question. It's been something that I've kind of noticed over the years in Freenode when we go to talk about pen testing or have questions. It's so easy to get slammed on, oh, how do you not know that? You stupid noob, that's not cool. Don't ask that. And you just get spammed out of a channel and so much hate mail. Or it has a project behind it, and it's like, say, Metasploit. So we can't really go in the Metasploit channel and ask about wireless pen testing. It doesn't fit the scope. So I wanted to present one out since I was developing some projects that people could talk about it and not feel like they're locked down to communicate about that project only. So it's a great channel that's starting. I hope everyone can lurk and have a good time in there. According to my code, as you'll see, I'm very strong in open source development. I believe that knowledge should be free to all people, and that's man's right. So creating things in open source is a way that I can give back to the community and a way that everyone can learn from what I've learned and develop it further any way they imagine. Because the way I do it's not always the right way, or it's not the way you want to do it. And the beauty of open source development is a process that you can change it and create it however you want and envision your life to go and what you want to do in your code. The last one is my blog, is the WordPress. My blog is just about pretty much everything that I'm working on and doing. I'll let you know when I release new stuff and have some cool little blurbs to go with it. It'll also continue on soon to be, I'm going to add more like tutorials on some hacking or walk people through. I know there's a lot out there, but the blog's been getting good feedback, and I wanted to keep going and building with that beyond just my projects and the things that I do to help the community a little bit further. So let's go ahead and move forward a little bit and understand what we're working with. I kind of explained who I am as a developer. I don't consider myself a code monkey. I consider myself more as someone that develops with a process of how do I solve a problem and create a solution with what I experience out in the field. What can I do to make what I'm doing easier and give it to the rest of the community to make their pen testing go a little bit smoother for them, less hassle. The proof of concept of how this application started is kind of a good evolution in its whole goal. It originally started as I want to do a proof of concept on point of sales exchange vulnerabilities. And that was really fun. But what did that take? What would that require? Well, anything on point of sales, if we're going to have access to it, is going to be a lot of man-in-the-middle type work. So our work's going to be based on controlling the adapter interfaces. What can we do for packet injection, packet capturing? How can we use Scapy to work that way? And how can we stay undetected in that process? So in order to do that, we first realized that we need to control the interfaces in many different ways. And then we also need to control the firewall rules to keep that information, either our information from going out or their information from not traveling out. So how could we do that? Well, the first way was I used a hub, an old collision hub. I know we're so used to switches now and managed switches, but everyone forgets that there's an actual hub out there, and it collides all the information coming in. So if I can bridge that, or I can put the connection coming in from a point of sale system into a hub, and I can plug my machine into a hub, maybe I can use another adapter on my machine into that hub as well, and then I can say within the code, okay, read everything coming in, don't send anything out. Okay, well, I'm just capturing. Okay, well, read everything coming in plus allow it to go unhindered. So the destination from the point of sale system would always see all the information that it was supposed to see, and you are invisible still at that point. Because in the firewall, you can say, don't send any information from me out, but only allow what's coming in from the first interface to go out. So you're invisible at this point. Well, that's good reconning, good time that you can just read the packets and say, well, maybe I want to change some values. Well, you have all the values from the originating machine, so you can use KB at that point and say, well, change the value, go ahead and send it out as that machine from you. So you change the value that the point of sale system was sending out on your machine without it ever being detected to which destination. What could maybe we do fun with that? I don't know, if I'm at a restaurant, maybe I can get a point of sale system and find out what it's printing and where it's printing food orders. I can just change a table number, put some food on there, and have free food delivered to me. Cook doesn't know the difference. It's still printed in the back. So there's a small circumvention that you can do, and that can go a lot of places. And as you can obviously know, any type of man-in-the-middle work is fun. How else could I do with that? Well, what if I'm reverse engineering software from a VM? The foundation in the firewall is already there, and it's already there to control the adapters. Now, yes, we can do that. We can write our own firewall rules, and we can use BRCTL and create bridges and bridge the interfaces ourselves. That's so time-consuming, and then it's a hassle dealing with the DHCP ranges, bringing your adapters up and down, just managing it. Like, man, this is just a real pain. Every time I want to test something, it's an hour getting started sometimes, or, half hour. It just depends. And if you want to change direction from where you were going, you have to bring all the interfaces back down. You have to restructure them and then set their values as accordingly, DHCP conf and the services. So I wanted a way to automate all of that the best way possible. So that was the original process that evolved for N4P, and it worked. Like, all right, yeah, this is cool, this is great, it works for me. But what else could I do from at this point? Well, what can we do when we're already really controlling interfaces at that level? The logical thing is to add some wireless work in for some wireless pen testing, because that's always fun. And we can keep it as a framework as it builds together. So I started to add the wireless penetration testing in with, WPA2 work initially, and then some web. And how can I crack it? So we use, AirPlay to crack things. And then we can, or AirCrack, and use AirPlay to kick people off if we want to do, flood the services to get people to de-off. So those started being added in as just quick values that you can press a button and it's done. That was what I really want to get. How can we make this fast and effective for everybody? Well, that evolved further. As it started to work out, other people were like, hey, I kind of like this, but it's not commercial ready. And that was my first endeavor going into what does it take to make an app be production ready, out for anybody's system. And that was crazy because it works on your system, definitely does not work on everybody's system because they are so different, so complex. So it became a long coding journey of how can I accommodate as many people's systems as possible. And the structure of it was, I built it off Pen2 Linux because I'm a Gen 2 user. And I love Gen 2. Don't hate me. I know it's a lot, but I love it and I'll always use it. And Pen2, I think, is a fantastic alternative to the in-depth granular work that it takes to use Gen 2, and it comes with all the penetration software already packaged in the repos. So it's a perfect start for anybody to work from, and it's in the repos. So if you did run Pen2, you could just emerge N4P now and start using it. It is kind of beta tested out there, is how I have it. So you do have to keyword it because it's always very volatile software. It's evolved so much over the past year that I've been writing this. I am the sole developer, so if anybody ever likes to contribute, please do to help get things out faster for you. Now, if you were at the DerbyCon talk, I presented the software back in about 1.0 range. And it was just leaving what the basic beta was, where I felt everyone could really use it. It had some good initiatives. You could go ahead and do good WPA cracking. You could do some WPS as well, was added in at that point. And I made some promises to you guys at that time. I promised that I would get WPE in, which is for radius enterprise hacking, wireless networks. That's in. Yay to me. And I also promised a stronger cracking algorithm would be put in, because we just used AirCrack and it was off a dictionary. This is nowhere near good enough for WPA2 and for enterprise type software. But it was a proof of concept, it was coming. So I promised I'd put Hashcat availability in, I did. So now you can directly crack with Hashcat your capture files, and it will convert the PCAPs into HCAP files automatically for you. So it's a lot of time that is saved for everybody. I think you will really like it. One thing that has happened doing that is N4P originated, and one of the reasons I thought about not really releasing it is because it super script kiddified the process. It's like, are you really even understanding what you're doing anymore at this point? Because you're just press a button that says go and follow the instructions, and you hopefully get handshake and hopefully it cracks. It still does that for WEP and WPA2, sort of. Well, in order to put such things like WP in to control airbase, control host APD, and control hashcat, or use hashcat for cracking things more complex. Anything time gets more complex, the code base and the configurations of it also become more complex. So it's really started to evolve past the script kiddie level to you need to either at least very well understand your system, what you're doing, or have an understanding of what you're actually doing and attacking. So I'm proud that the evolution has happened, but that is some feedback I've had in beta testing that people got a little confused. Well, I ran it and it's giving me this error. Well, did you go through the configuration file and validate that everything is set accordingly for your system configurations? No. Well, let's start there. So according to me making all those promises, I kind of thought I felt like I was doing this. If anybody remembers GoldenEye, that's what I thought I would be doing in crushing Russian satellites. If you can't see it, that is Boris from the GoldenEye film. What actually ended up happening was more like this. That was a swordfish theme, since it's kind of done, if I remember swordfish. But the reality ended up being that I had 99 little bugs in the code, and now I have 127. So, we talked a little bit about what you can do over the wired version, over Pen2, the possibilities of point-of-sales exchange vulnerabilities, man in the middle. I want to talk a little bit more about how you could utilize that for reversing software. What if most popular thing you're going to reverse is going to be on Windows, because everything's closed source, and you're probably looking for a key, maybe you're a reverse engineer, maybe you're working on something to crack. Maybe it does online activation. So a great way we could handle that is we could just open the software up, tell it that we're going to do some bridging mode, and we're going to actually use an AP, or we're going to use a bridge directly to the VM. Because it can also handle this through an access point, through AirCrack suite, which normally can't be done because you can't just bridge a wireless interface, but if you create an AT interface off of the monitor mode, you can bridge that to another adapter. So if you put it up and you had a separate machine it running on, because maybe you don't have a VM, you can connect that way. So if I'm cracking the software like this, I want to monitor everything that's coming through the system, packet-wise. All we have to do is open Wireshark, and we can control it a little bit more in depth, which we'll get into how we can actually control those packets for cracking. But basically what you're going to do is you'll see all the stream coming in, and you're going to reverse that to find, well, how is it authenticating? Okay, so maybe I can change my host file, make where it's authenticating, look back to me, and force the injection over. That way the software authenticates. Something you could do. These are all kind of the availabilities that I've built in that are the thought process of what I can do from this software. I can denial of service systems by kicking people off. We can man in the middle our connections. SSL strips built in, so we can circumvent SSL if we spun up an AP at a coffee shop. They wanted to, steal people's credentials. The WPE process is brought in for wireless enterprise hacking. We went over packet injection a little bit, but you can use escapee. We went on to packet capturing if you want to run Wireshark and capture. WPS is built in. For WPS, it's using wash and bully, if you're familiar with those, for WPS cracking. VPN control is built in as well, and that's something that nothing else out there really has. In order to run the VPN, it's not always on, and it's controlled through the firewall. So if you set the variables when you want to run an attack, this can go back into man in the middle and running rogue access points. Maybe I want to run it through a VPN, or maybe I want to run it through Tor, or maybe I want to direct them to a private portal. So we have the control built in that the people connecting or you connecting go to a private network. You can redirect them where they want, and they won't know it. Those are things that are usually a lot more difficult to spin up on your own on an attack. WEP is obviously built in. That was always there, but it kind of wasn't always there. I just kind of pushed the features through a little bit better, so now it's kind of one button availability. We just spoke about redirection. WPA2 handshakes is a part of the process that we'll see as an attack vector that we can choose. DNS spoofing, as we talked about, you could just change your DNS when someone is on an access point and spoof where they want to go, where you want them to go. If they're trying to go to Facebook, it actually redirects to you, 12700. Do whatever you want. How we can use it for cracking, and we can still use it for phishing based on, we can steal people's emails account this way and maybe understand what they're going to look at, what kind of sites they're visiting, what type of banks they're going to, build a portal, and then spin up the portal next time they go to it. They think they're going where they want, but they're really going to what you've designed. So don't limit your thoughts on, it's only a module, it's only a framework for doing wireless hacking. It can go pretty much anywhere you kind of imagine to go, plus it's open source, so go ahead and write some code if you don't like it. Now, I talked about where I was as a developer, and I don't consider it a code monkey. I don't develop all day long. I pen test, but we still love to develop, and we understood as a pen tester that having the ability to develop and developing is a key principle to being effective and evolving in our position. So I like to develop my code in the same process, that I'm giving you guys something that will make your lives much better out there as an offensive individual. Okay, so as the project went on with work, the timeline theory says, I do this a whole lot, so I'm going to start automating it. So that's what I did. And now you guys are seeing the automation process, and it has become an ongoing development, as we've explained. And down here, someone can contest, I no longer have time to work. That's why I encourage you to help me out. Why it's open source. All right, let's go ahead and talk about actually hacking, and I think we should play a game. And if you ever do go through my code, I have a lot of Easter eggs in there, and they all reference really cool stuff. So when you have fun, feel free to shoot me an email and tell me each Easter egg you find. Injection. Yes. I did steal the hamburgers. It was me. We kind of went over of how it can work. This is an attack vector that we can use our modes and our bridging capabilities to inject packets. Pretty simple. Any questions on how that might actually work? No? Good? Hey, it doesn't let me do that. Okay, it's going to go a little bit into the firewall at this point. Why does the firewall kick ass? Because it's totally based on the configuration file in the software. I pretty much built a firewall that I think everyone can always use that would be excellent because it is stateful by design. Its initiating principle is to drop all packets, and we only allow what we need. So I've allowed a small amount that I think everyone needs, obviously, like 80, 445. And you can go in as you want and start adding new services. Because it's stateful, anything you ask for is going to open, so it's not going to hinder your system any if you want to run the firewall full time or if you only want to run it during N4P. It's your choice, but I try to make it where I think people can always use it. And it's based on IP tables, so anyone on Kali might have some issues because I think they run a little bit different init structure on that. What this is mainly based on a lot for the VPN, for bridging devices. The deeper network controls is what I originated it for. As you can see in here, as it says VPN equals true and allowance the processes. In the configuration file, you have to tell it, yes, I'm going to go ahead and use a VPN for this attack. And then you will name it. And then according to the name, if you're familiar like OpenRC, you can have multiple VPN's access. So it's etc init.d first openvpn dot the VPN name you want to launch. Well, if I have 4 different VPNs, how do you know which one you're launching if you just call openvpn? You don't. So according to the configuration file, you can specify the name of that VPN that you're wanting to launch, and it will automatically populate it in a variable and start that VPN. Or if you don't have the control in there, it's not going to do it. But this control goes quite a bit further. That's just an instance. That's in every variable situation that we have. Let's go ahead and talk about what happens if we're bridging on the firewall rules. If we bridge this and we're going to use an access point, well, it's going ahead and it knows if you don't bridge it, it's going to forward the packets. If you do bridge it, it's going to forward everything through the bridge. And the way we do that is we're going to allow the interface through on a stateful process. But I have commented 2 lines in the middle that allows you to multi-port control or restrict that interface based on a port spectrum. So you can granularly control what's going to happen on the victim's machine that's going to pass through yours based by the port. So that can really help you in aspects of when maybe you're doing, if you're doing an authentication audit or a web application authentication, so you're trying to find that, you can restrict all the ports that are being fed through that AP down to just port 80 or 445 or 443 so that you can see it better and not just get so overwhelmed with the traffic. So it was just a cool way that I could put things out there to help you process what's going further. The same principle applies through like SSL strip. If we've changed our attack methods to use SSL strip, it's going to change the variables in the firewall. So if you know your attack requires a firewall configuration, port redirection, device control, you're going to have to run the firewall. But it's good enough to know that the firewall is going to base its rules and not allow anything it shouldn't allow through. It's always going to base it on the configuration file. So that's why it's important every time we need to go visit the config file. Can everyone see that okay? Kind of? No? No? Yeah, I guess there's no way we can fix that, huh?
Can you turn the lights off?
Please? That helps? A little bit? All right. Just because that helps a little bit, I'll let you check out the firewall rules again. Maybe you can understand that more. All right, and we'll revisit that one you still can't see. Okay, sorry about that. I wish you could have seen that one. Well, read my code. It's on GitHub. Let's take a look at the interface of how we're controlled. What we'll really see here is a basic interface of choices. And these are predetermined variables in strings that you would apply through the terminal that I've put together just to be quickly accessed at any point. Because my principle is I use Gentoo and I can't remember any more lines of code. I just can't. And there's a lot of code, a lot of commands and flags are passing between each attack vector, and it gets overwhelming at times, and you just forget. Face it, we just forget we're human. So the first thing is, on this one, I think I've changed the numbers on the latest version. Actually, I have a place I can jump to it to show you a better screenshot. So let's move over to the right. What you see is /temp/N4P. Anything we do in N4P is going to store in here. It doesn't remove it right away when it closes, but your system will remove it because it is in temp. So we have all our log files of anything that's going on with anything that we're running. If we have an error or something crashes, we can visit the logs. But we also see in here we have our capture files. And it captures based on the SSID or the BSiD of the access point that we're attacking, the .cap. So when we run like a recon and know what we're going after, it's going to list the BSiD, the ESSID, and the station of that access point that we're attacking. Well, it's going to automatically save it as that BSiD because that's part of the configuration files, which we'll get into. So that's how you can keep track of what you've actually are going after and attacking. So if we're only done one, this is the BSiD that will be in the config file. So when we perform next actions like cracking or converting, it's automatically going to look for that one. So if you did like 3 in an engagement and you want to use the software to also do cracking, you're going to go back in the config file and adjust the BSID to match which one you're going to go ahead and crack. So it's going to look there, it's going to convert that file over to an HCAT, and then it's going to go ahead and run hashcat on it based on the string structures that you've passed in those variables. Now, what else do we have in options? We have the config. We can run a radius right away. So we just press one button, and it starts running our radius recon, where we see everything that's out there. After we see everything that's out there, we're just going to find what one we're going to go after. We're going to adjust the configuration file to match it. Then what I'll do is go back to our initial framework and press, button 3 or button to bring up arrow dump. So now we're going to go ahead and watch that interface. And then if we want to capture, say, handshakes, if we're doing a WPA2 attack, we can just press 5 to launch the access point. The access point will come up, it'll capture a handshake, it'll tell you, it'll save it in the configuration file. We come back down, then we crack it. If we didn't catch a handshake, you can press like option 7 and deauth everybody to try and get another handshake there. But what else is there? Well, we talked about things like SSL strip and EtherCap as part of the process. So if we didn't want to do the handshake attack, we can change in the configuration file to use null and just launch an access point. Well, okay, we have an access point up. We have people that could connect. How do we know they're connecting? Well, we also have a monitoring interface built in that comes up, and it will monitor your log files for who connects. It'll automatically give you the IP address of the people that connect, are connected to your AP, and then you can run things like SSL strip from here. So I run SSL strip on it. I can run EtherCap on it right now off just pressing the button here. Those come up, and now you're stripping off the SSL that these people are using, and you're watching the passwords come through on EtherCap live. So maybe that's a coffee shop fun for somebody one day. All right. We can ARP the network as well. If we're plugged into a corporate network, I tend to like that more. If, maybe I'm pretty isolated or I moved down in a different zone and I want to ARP some traffic over to me just to see what's out there for a minute. Just press the button and go. I try to add as much useful things as I can in the basic interface. You can also see in the middle is the enumerate firewall spectrum, because if you're going to run SSL strip, you have to go ahead and change the firewall at this point. So run it, it will re-register from the config file that we're now using SSL strip, and then the firewall will populate accordingly and the ports will be forward as they should. There's also, which is really big, this is where we're really starting to get into the framework design. I wanted to keep the simplicity that we went over in for everyone to have, because it's quick, it's easy, it was the initial process of it. But it's not where I fully want to go with the direction of the project. It was the initial proof of concept that I wanted to develop. So now we have advanced mode. We simply get there in the option mode by typing advanced. And at any point when we do that, this becomes our only command prompt, N4P $. At any point, we can type basic and go back to the initial screen where we see all the numbers and what we want to do quickly. But also, even in advanced mode, you can just press 1 through 9 and still execute that action. So if you know the config file is always option 1, at any time you can press 1 and enter, even in advanced mode, and bring up the configuration file for editing. So what I have built in are module designs. I've broken N4P out in all its processes into individual modularizations. And I even have an example module in there so that the base structure for what the variables need to be are there, and I show you how to add any type of variable you want for your own module. So you can still continue to create your own variables, and it will process through. If you load your module, it will read it for the first time and say, hey, this is the first time I see in this module, I see user customization variables. I'm going to load them in the configuration file. Then it will exit. Now you need to go back to the configuration file and change the variables that have been populated for the new module that someone has created for you to use. Currently, I have one in there for Airbase. I have the ability for bridging. I have bully in there. I have the ones for cracking, which we use aircrack and hashcat. DHCP for launching the DHCP service. The way that works is the first time that you ever use N4P, I've designed or set up a DHCP range that I'm going to use just for serving my access points, which is a 1010 network. It populates it into the DHCP conf file the first time you ever run it. It never does it again. It checks to make sure it's there every time. So if you don't like those ranges, you can always just go into DHCP conf and edit the ranges you want to use. But 1010 is what I chose. There's one in there for host APD. Why is host APD in there? Because it is pretty easy to design as an access point, but we use host APD for the WPE configurations. WPE on this design, because it's for Pent2, you do have to patch host APD to attack WPE networks. And for Kali users, you do have to compile that patch in. If you use Pent2 or Gentoo with the Pent2 overlay, we build everything by source, and these patches are already applied in the use variables. You just have to say, I'm going to allow the use variable of WPE, or I'm not going to allow it. That way, when it compiles it, it'll automatically compile those features into host APD, and we're ready to go. So from a Pent2 and a Gentoo perspective, if I'm offering you WPE, it's automatically going to work. All right. Further down, I have the monitoring mode, and monitoring just allows you to view anybody that connects to your access point, give you their IP addresses. The IP table strips, reconning was to recon for seeing, just to populate or view all the SSIDs out there, all the wireless access points. Wash for, performing WPS and WPE further down. Host APD will run on its own, but WPE will be part of the attack. If you know all your modules, you can run the full attack here, launch each module at a time. But if you choose it from the options menu up top, it knows what order it needs to do things in and what item modules need called to perform that action. So it will just do it for you. The reason I like this is not only because it's modular, but because if I'm performing one attack and I just want to see something extra, I can't really do that before. So now in advanced mode, I can still be performing an attack and just go ahead and launch one module to see whatever I needed to see extra. So it's a really great feature. And each launch is standalone. It pulls it off uses Xterm to launch a new terminal to process whatever action or module you asked it to do at that point. So as long as you're not bringing up more than one airbase, because we can only pull up one airbase interface, but we can pull up multiple monitoring interfaces in different cards, we can keep launching it over and over again and change the configuration file between each attack to expand our horizon of what we could procure in this manner. Now, to use the module, how do we use it? Well, everyone use Metasploit? No, half the people use Metasploit. It's a red team, guys. Come on, everyone's hand should be up. All right, I try to follow the same process because it's something that everyone will be familiar with. So when we want to use a specific module, we type use the module name. It loads the module, and then we just type run to run the module. So it's pretty simple in that prospect. Well, I think we'll get to that in a minute. Go back here. There's something else that we also need to check and do. I wanted to show you the config files. Wow. That's strange. I lost a slide went missing on me. How not cool. No. I really do want to show you the configuration options. All right, here we go. Hopefully you can actually see this as well. Can we see any of that?
Bigger font.
Bigger font, huh? Zoom in, I can't see. Scotty, I can't see. All right, no, we can do that. Here's how we'll do that. Okay, so we'll CD into programming and N4P. And we can just launch N4P.sh. All right, so here we have a live demo, and it's kind of scary. I didn't even ask the demo gods if I could do this, so hopefully they are kind. All right, when we first run, it checks between different types of interface controls, like, what is it? No, I can't remember the name of it because I use it. Oh, Network Manager. If you use Network Manager, that causes a lot of problems with controlling adapter interfaces, especially in the wireless spectrum. That's something I noticed, and you have to close the service down on your own manually. So I kind of added that in recently. That way, if it checks if you use Network Manager, and if you do, it automatically turns off the services, as we can see, inactive. So any services that I had running that could interfere, that I know interfere, I'm automatically shutting down. And when we exit N4P, it calls a very specific rebuild script that it rebuilds all the interfaces according to what they should be before it leaves. That way the system is left sane. That is an issue when we're doing a lot of wireless work. The system is very rarely left in a sane state as far as the network adapter interfaces go. So we go back through, it shuts the firewalls down, it brings all the interfaces down, it kills all the wireless ones, and then it reinitializes your main interfaces that you use, like E0 or WLAN 0, whichever you've told it that. So it knows how to get you back to a sane state. So if we check the configuration file, I said it's gotten a little bit more daunting over time. So we can see here it says OS Pen2. I originally only designed this application to work on Pen2. Through time, in a lot of people's requests, I've pushed it out to work a little more on Kali. I've only gotten like the wireless to work. I can't get the adapters and bridging to work yet because that relies specifically on the OpenRC init system. And obviously Kali does not use OpenRC. That's a Gen 2 thing. As far as working on Windows, I just don't care about you guys, so you're out of luck. All right, so we see Network Manager equals true. That means I'm using Network Manager. So I need to check and shut that service down before I do anything. So if you don't use Network Manager, that will just be false. For interface, we're starting basic. If you're just uber elite and you always want to use the advanced interface, you could change it to advanced. It's just where you want the application to initiate as when you first start it up. Because you can always just type basic and switch back at any point as well. Now it's broken up to, like, you see wireless options, network options down here. This is just what are we going to control for our wireless operations. For access point here, we're using Airbase. We could use host APD if we change it to host APD, but we're just going to use Airbase here. Now, what is the main interface we are using on our system that's connected to the internet? For me, I'm usually plugged in, so it's ETH0. But that could very easily be WLAN 0 as well. So then it goes on to what adapters are used for the attack. All right, well, for the attack, I'm going to use WLAN 0 or WLAN 1 if I plugged in an external card. Depends what you want. So you just change the iFace 1 for the attack to be that. What are we going to name our ESSID that we're going to show the world? Maybe we're just launching an access point. So we need to name it something for them to see. So we're going to name it Pent in this case. Create whatever BSID we want, what channel we want it on, and then if we're going to, how we're going to monitor the people connecting. Custom, we use DHCP dump or ARP. If we're using host APD, we have to set where the configuration file is. And if we want verbose logging while we're using this application. So that's just our wireless controls. Then under your bridging options, we set, if we're going to bridge, true or false. What's going to be the name of the bridge? Usually BR0. And if we're using a VPN. We're not using one in this case. So those are what the firewall rules are going to check each time it loads to repopulate its controls. But there's more, Captain. Yeah, I said it was pretty daunting. Attack options, or how are we going to attack on this wireless attack? So our attack is null right now. It says attack equals about 5 lines down. If we want to do the handshake attack for WPA2, we change that to handshake. Karma, if we're going to attack with SSL strip, WPS, WP, or WEP, we set that here, and then we can run our module or our attack option in the interface. And it rechanges all the variables as the way it calls aircrack or the way it calls host APD and its flags to match accordingly. If we're using WPA2, we see type equals Z and what the types you need, which would be obviously in -s help or the man file of aircrack suite. That way, if we're using WPA2, I know I'm going to use Z. Z's in there because I use it the most. The encryption type for Z is 4. And then when we ran the recon, we're going to see what we're going to go after. At that point, we've copied down our victim's BSides. So we're going to put it in there, in the victim station. And WPE config is, if the attack option was WPE, this is the location that the configuration file that host APD needs to look at to perform a WPE attack. If you use Pen2, this is the default location, this is where it will be. So it's automatically set up. If you're using Kali, obviously you're going to have to adjust it for wherever you put that configuration file that is part of the patch when you apply a patch for it. Packet options are just how we call ettercap, and if we're ARPing that victim. Now here's where it gets really crazy now, since I said I would put in hashcat, and I did. This was pretty difficult, believe it or not, because hashcat is very sensitive and it's very complex. Alright, so we have my mousey thingy here. Alright, so for crack, in this crack case, it's already set for aircrack NG. So if we ran simple option or ran a crack method, it would just run aircrack against the dictionary. We need to change this value to hashcat to use hashcat. And if we're using it, we can list here where our word list is, what type of hashcat version we're using. Are we using OCL64 for GPU cracking, or are we using a CLE based on CPU cracking? Just depends on what our options that we have available to us. The location of where hashcat is stored, because hashcat uses a time bomb binary, you have to constantly update it. So I can't keep a solid version in here. I have to allow you to adjust what version you're at or where you're storing it for a folder. The mode 2500, because we're defaulting for WPA2, but it doesn't limit you that way. If you're going to use NTLM hashes, maybe you're using Responder to capture NTLM hashes, put it in here. If you just kind of move the hash over there, or you set it up because this is what you use it for, you store all your hashes in N4P's folder, you set the value to 5,000 and you go. And it's a good way you can still utilize the functionality. How many threads are we going to use? And then what rule sets we're using. In this, I defaulted it to Mangle, 2 different rules, the RockU and best64 rule sets. Now, I'll read this out to you. It's part of the configuration file. It says, hashcat is complex program to syntax for, if you know what you are doing, modify away. A quick hack tip, if you don't want to use rules, then eliminate the options by the below example. If you want to use the rule, use brute force wildcards, do so by placing the commands in the word list equals section, such like word list equals, instead of the location of the word list, -A3, question variable, and increment where you want to start the attack from. So I'm going to use 2 variable spaces with a minimum of 10 and start point at 588 million positions. So you don't even have, just copy paste, adjust how you want, and hashcat will re-interface itself. I try to make it accessible to as much user modification and flexibility as possible. But if you mess up, obviously it's going to crash. So don't mess up. On creating custom modules, you see down here, it also tells you more about custom modules. And if you read the module example, it'll be explained in there. Name yours my custom module, and not just custom module because it'll conflict. But that you can get into if you start wanting to develop modules. So that's the configuration file interface, and I'll just show you I can type question at any point. Question gives me my possible commands. Use recon module. There it is. Oh. I should go to advanced first because I am confused. Use recon. It loads it, and we can just run it at any time we want and list modules, and we can go back to basic mode. So that's our basic interface here. Now when I exit, as I said, it's going to call the rebuild scripts, and as we see here, and attempt to rebuild my network. And we're done there. So for closing here, what's funny is my slides that were missing just populated themselves back up. Nice. See, because there they are. All right. So where is N4P taking us, and how is this project changing the entire script land space of wireless hacking? And it really is. If anyone is familiar with Zero Chaos or Rick Farina, he is one of the lead developers for Pentesting Linux. He approached me a couple weeks ago, and he wants to kind of deprecate and merge all of our code and create the new base standard for what will be wireless penetration testing for everybody. Why is this so cool? Because we're going to use a lot of new init system script hacks that will bring basically N4P's design framework and modularization to all Linux platforms. So it's moving away from just Pentoo. So when he asked me, hey man, do you want to be a part of this? I was like, well, I'm kind of enjoying my project, but wait, it can be available for everybody? Heck yeah, I'm in. Yeah, let's get everyone this code, get everyone this stuff to use, and create the new de facto of what we're going to be doing out there. Because we have one for social engineering, we have SET. We have Metasploit for our network framework designs, but we don't really have anything in the wireless space, or in with the addition of controlling things like your VPNs and your bridging and man-in-the-middle type attacks, which is even a whole nother spectrum. So to me, I look at this and it's bringing the industry of where we're going into a nice circle and all to unified us together of what we're going to be doing in the future. So I'm really excited to see where that's going to start going and bring us. So as far as any new major code changes, I'm not going to be making them. I'm going to continue to support N4P, its code, and any bugs that anybody finds. In addition, they're like, hey, yeah, I need to tweak this code a little bit. I'm on it. And we're taking it from where we're at here. And we're also using the Pony Express code. So Pony Express will be coming open source with us. So a lot of that code, we're going to take some of the Pony Express code, N4P's code, and some stuff from EasyCreds, if anyone remembers the deprecated EasyCreds software. We're taking all three of these projects and we're using them to make what is going to be the next standard for everybody. So I'm really excited about that, and to say the least, that slide basically says it. It's code for all the platforms. And right now, our platforms, as I said, just so you know, it's Pentoo and a little bit of Kali. And that is my closing notes. If anyone has any questions, I'll be here. I hope you enjoyed the project and where we're going with this.